Assalamualaikum warahmatullahi wabarakatuh. Introduce, my name Muhammad Iqbal Setiawan, student identification number 1207050064. I'm here as moderator from Group 3. We'll present the event during the presentation on computer architecture. For this first material about anatomy of computer will be brought by Jalalul Mukti.
Yeah, thanks to moderator. Okay, introduce myself. My name is Jalal Murti. I'm going to explain about anatomy of a computer. Anatomy of a computer. Anatomy of computer is a science that studies the composition or structure of a computer. The computer has two important components. Uh, it is a microprocessor and memories. Microprocessor have two types. It is CISC microprocessor and RISC microprocessor. Okay, next. What is CISC microprocessor? CISC microprocessor stands for Complex Instruction Set Computer. CISC microprocessor developed by Intel. Then CISC is a type of design for the computer. And CISC based computer will have shorter programs, which are made up of symbolic machine language. And the number of instructions on a CISC processor is small. And this is an example of CISC microprocessor, an Intel X86 and AMD CPU. Okay, next. What is RISC microprocessor? RISC stands for Reduced Instruction Set Computer. Reduced Instruction Set Computer. And the properties of RISC microprocessor are a large number of general-purpose register and use of computer to optimize register usage. Then a limited and simple instruction set, and less an emphasis on optimizing the instruction per line. And this is an example of RISC microprocessor. This is PowerPC 600 and UltraSpark CPU. Okay, and the second material is memory. The memory in a computer is made up of semiconduction. Semiconduction memories have two types. The first is RAM or random access memory. In the RAM, the user can write the information and read the information from it. The RAM is a volatile memory. It means information written to it can be accessed as long as power is on. As the power is off, it cannot be accessed. The RAM have two basic types. The first is static RAM and the second is dynamic RAM. Static RAM retains stored information only as long as the power supply is on. Static RAM are costlier and consume more power. They have higher speed than dynamic RAM. And second is dynamic RAM. Then dynamic RAM loses its stored information in very short time, even when power supply is on. And dynamic RAM are cheaper and lower. Okay. Then it is the other RAM. Some other RAM. The first is EDO RAM or extended data output RAM. Then SDRAM and SGRAM. SDRAM is synchronous dynamic RAM and SGRAM is synchronous graphical RAM. And the last is DDR-RAM. DDR-RAM stands for Double Track Synchronous Dynamic RAM. The second memory is ROM, or read-only memory. ROM is volatile memory. The information stored in it is not lost even if the power supply goes off. ROM used for the permanent storage of information. Information cannot be written into a ROM by the user or programmer. In other words, the contents of ROM are decided by the manufacturer. Then ROM have three types. First is PROM, second is EPROM, and the third is EEPROM. PROM is programmable ROM. Its content are decided by the user. The user can store permanent program, data, and other in PROM, but the data is fed into it using a PROM program. The second is EPROM. EPROM is erasable programmable ROM. The stored data in EPROM can be erased by exposing it to UV light for about 20 minutes. And the last is EEPROM. EEPROM is electrically erasable programmable ROM. The chip can be erasable and reprogrammed on the board easily byte by byte. It can be erased within a few milliseconds. Okay, next. The next material is flash memory. Flash memory. It is an electrically erasable and programmable permanent type memory. It uses one transistor memory, all resulting in high packing density, low power consumption, lower cost, and higher reliability. The flash memory used in all-power digital cameras, MP3 player, and other.
We get to know about anatomy of computer, which is brought by Jalalul Mukti. Then the next we will discuss about basic computer architecture. That will be brought by Ilham Rizky Agustin.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ilham Rizky Agustin. Here I will explain about basic computer architecture. The first material of basic computer architecture chapter is memory module. Memory modules are divided into two types. First, SIMM or single inline memory modules, and DIMM or double inline memory modules. These are small printed circuit card or PCC on which several DRAM memory chips are placed. Such cards are plugged into the system board of the computer. The SIMM circuit card contains several memory chips with contact placed on only one edge of this PCC, whereas in the IMM, it's on both sides of the PCC. Next, the system clock. The clock is designed by a piece of quartz crystal. The system clock keeps the computer coordinate system. It's an electronic system which keeps oscillating at specified times interval between 0 and 1. The speed at which this oscillation takes place is called the cycle of the clock. Next, the system bus. Bus means the electronic part between various components. Bus refer to particular types of a cable. Each cable of a bus carries information of one bit. Bus are of three types. First, address bus. It carries the address of memory allocation of required instruction and data. Next, data bus. Data bus is an electronic path that connects CPU, memory, and other devices. Data bus carries the data from CPU to memory or input to output devices and vice versa. And last, control bus. Control bus controls the memory and input or output devices. This bus is bidirectional. The CPU sends signal on the control bus to enable the output of the addressed memory devices. And last, various cards. Various cards are of three types. First, sound card consists of microphone and speaker. The sound card converts the sound into computer language and vice versa. The main part of sound card is DSP or digital signal processor, which use arithmetic logic to break out sound effect. Next, ACSI card or Smart Compute System Interface. This technology is used in high-speed hard disks. Is often used in server where high volume of data is used. The capacity of the ACSI is determined by the bus width and speed of the interface. And last, network card. Network card is the versatile device because it performs a number of tasks that contribute to the entire process of transmitting and receiving data between computers. It links a computer to another computer of the network card through cable wires. A 7-layer model of OSI or Open System Interface is used in the Internet for receiving and transmitting of data. Thank you for your attention. For next material will be explained by my partner. Thank you.
We get to know about basic computer architecture, which is brought by Ilham Rizky. That's the next we will discuss about input output device that will be brought by Indri Novianti.
Assalamualaikum warahmatullahi wabarakatuh. I'm Indra Noviani and now I will explain what is input-output device. The devices which are used to input the data in the program in a computer are known as input device. These devices convert what we input into a form that is understandable by a computer. It provides man-to-machine communications. Some of the input-output devices are explained below. First, keyboard. The data and instructions are input by tapping on the keyboard. The message type on the keyboard, which is the memory unit of a computer, is connected to a computer via a cable. Apart from alphabet and numeral keys, it has other function keys for performing different functions. And next, mouse is a pointing device. The mouse is rolled over the mouse pad, which in turn controls the movement of the cursor in the screen. We can click, double-click, or drag the mouse. Most of the mouse have a ball beneath them, which rotates when the mouse is moved. The ball has two wheels on the side, which in turn moves with the movement of the ball. The sensor notifies the speed of its movement on the computer, which in turn moves the cursor or pointer on the screen. And next, this scanner. Scanners are used to enter information directly into the computer memory. This device works like a sewing machine. The scanner converts any type of print or written information, including photographs, into digital pieces which can be manipulated by the computer. And next, like pen. This is an input device which is used to draw lines or figures on a computer screen. It's touched to the center of the screen where it can register on the screen. The next, optical character reader, is a device which detects alphanumeric characters printed or written on paper. The text which is to be scanned is illuminated by a low frequency light source. The light is absorbed by the dark areas by reflect from the bright area. The reflect light is received by the photocells. And the next is barcode reader. This device reads barcode and converts them into electric pulses to be processed by a computer. A barcode is nothing but data code in form of light and darkness. And next is plotter. Plotter is an output device that is used to produce graphical output on a paper. It uses single color or multicolor pens to draw pictures as blueprints. And next is trackball. Trackball is similar to the upside-down design of the mouse. The user moves the ball directly while the device itself remains stationary. The user spins the ball in various directions to affect the screen movement. And next is voice input system. These devices convert spoken words to MC language from a microphone is used to convert human speech into electric signal. The signal pattern in the transmit to a computer when is compared to a dictionary of patterns that have been previously placed in a storage unit of a computer. When a close match is found, the word is recognized. Is a printer and what are different types of printers? Printers are output devices used to prepare permanent output on paper. Printers can be divided into two main categories. The first is impact printers. In the hammers or pin strike against a ribbon of paper to print the text, this mechanism is known as electromechanical mechanism. They are of two types. Character printers. It prints only one character at a time. It has relative slower speed. Of them are dot matrix printers. Dot matrix printers is print character as combination of dots. Dot matrix printers are the most popular among serial printers. These have a matrix of pins on the print head of the printer which from the character. The computer memory sends one character at a time to be printed by the printer. There is a carbon between the pins and the paper. The words get printed on the paper when the pins strike the carbon. There are generally 24 pins. And a line printer. It prints one line of text at a time. At a time. They have a higher speed compared to character printers. Their printers have a poor quality of output. Chain printers and drum printers are examples of line printers. And the next is non-impact printers. Their printers use non-impact technology such as inkjet or laser technology. Their printers provide better quality of output at higher speed. These printers are of two types. First is inkjet printers. It prints character by spraying pattern of ink on the paper from a nozzle or jet. It prints from nozzle having very fine holes, from which a specially made ink is pumped out to create various letters and shapes. The inks come out of the nozzle in the form of papers. After passing through a reflecting plate, it forms the desired letter or shape at the desired place. And the next is laser printers. It prints the entire page in one go. These printers have photosensitive drum made of silicon. This drum is cooled with recharged photoconductive, which is extremely sensitive to light. This drum is exposed to the laser rays reflect from the shape to be printed. That area where the rays fall gets discharged. This drum, while rotating, comes in contact with toner, and the toner is attached to the discard area on the drum. Then, when the drum comes in contact with paper, the toner that has got attached to the drum in the original shape gets attached to the paper, and has printing takes place. The paper is slightly hit and the toner gets permanently attached to it. And the next is different types of printer. The first is thermal wax printer. It uses wax coat, ribbon, and heat pairs as the magenta, yellow, and black ribbon passes in front of the print head. Heated pin melt the wax on the paper when it hardens. The thermal wax printer produces vibrant colors but require very smooth or specially coated paper for best output. And the next is dye sublimations. It's a printer which employs a printing process that uses heat to transfer dye to a medium such as plastic card, printer paper, poster paper, or fabric. The process is usually to lye one color at a time using a ribbon that has color panels. And the last is iris printer. It's a large format color inkjet printer which is used for digital papers proving it used a continuous inkjet technology to produce continuous tone output on the various media, including paper and
We get to know about input-output devices, which is brought by Indri. Then the next we will discuss about storage devices and history of computer that will be brought by Muhammad Najib.
Hello everyone, my name is Muhammad Najibuddin Syahbani and my starter number is 1200135. Okay. In this section, I want to talk about two chapters. It's number one is storage device. Number two is historical of computer. In storage device, we will make it for part. Number one is overview, number three modem, and number two storage of device, number four is formatting. Okay, for number one, overview. Introduction. A storage device is any type of computing hardware that is used for storing, forwarding, or extracting data file and objects. Okay, next to number two is type of storage device. How we can classify storage device. Storage device or secondary storage device are used to store data and instruction permanently. They are used as computer to supplement the limited storage capacity of RAM. In the types of storage device, we will make it two types. Number one is magnetic storage and number two is optical storage. In the magnetic storage, we have three types. Number one is floppy disk, number two hard disk, and number three is magnetic type. What is floppy disk? It's a circular disk coated with a magnetic oxide and enclosed within square plastic cover. We can call it jacket. It's available in different sizes, but the most commonly used, the floppy, is 3/2. Number two is hard disk. Hard disks are made of aluminum or other material alloy, which are coated on both sides with the magnetic material. Unlike floppy disks, hard disks are not removable from the computer. Form number three is magnetic type. Magnetic type is type a mass storage device. It's used as a backup storage. It's a serial access type of the storage device. In this picture, you can see the example from the floppy disk, hard disk, and magnetic type. Okay, next is the type of storage device. In the optical memory, or we can call it optical storage. Information is written to or read from an optical disc or tape using the laser beam. Optical discs are not suitable memory storage unit because their access time is more than that of hard disk. The advantage is that they have a very high storage capacity. Type of optical memory are CD-ROM, CDR, CDR-W, DVD-ROM, DVD-R, and DVD-RW. Information on a CD-ROM is written at the time of manufacture. CDR-W of the half 700 megabytes are available. A DVD-ROM is similar to CD-ROM. It uses shorter wave length of laser beam and hence store more data than CD-ROM. Okay, you can see the example picture from the CD-ROM or DVD-ROM. You can see in chapter 3 we want to talk about modem. What is modem? Modem is an abbreviation for modular demodulator. Modem are used for data transfer from the one computer to another through telephone line. The computer works in the digital mode. While analog technology is used for carrying message across the phone lines, modem converts information from the digital mode to analog mode at the transmitting end and convert at the same time from the analog to digital at receiving the end. Modem are two types. Number one is internal modem and number two is external modem. Okay, number 4 or part 4 and the last from the storage device, we want to talk about formatting. What is formatting? The process of magnetically mapping of a floppy is called formatting. Before storing the data on a floppy, it needs to be magnetically mapped so that data can be stored in the right place. Every new floppy needs to be formatted for use. Formatting means the creating track on the sector of the floppy. Tracks are in the shape circle on the floppy which divide it into various segments. The number or tag define often the density of the floppy. In a high density floppy, up to 80 tracks can be created. Okay, go to chapter 5. We want to talk about history of computer. In this chapter, we will make it 3 parts. Okay. And number 1 is different era of computer. Number 2 is the computer generation, and number 3 is von Neumann architecture. In the point 1, we want to talk about the evolution of computer. Evolution of digital computer. The successful general purpose mechanical computer we are developed in 190-30. Mechanical calculation we are built for automatic addition, subtraction, multiplication, and division. A calculator is not a programmable device. The different era of the computer. Okay. In the mechanical era part 1. Okay. There are many attempts to create M or C that could help to perform papyrus calculation in 180-23. Charles Babbage tried to build a mechanical as a computing M or C capable of performing automatic mathematical calculation. This was designed to compute the table of functions such as the log function. And the mechanical era part 2, okay, is the next part from the part 1. In 180-13, Babbage made a powerful mechanical computer. This MRC was designed to perform any mathematical calculation automatically. It's called perform addition. It had a memory unit. Its capacity was 100 number. It's now consisting of 50 digits. The MRC was a programmable MRC. It had mechanism for enabling a program to chart the sequence of its operation automatically. Okay, next is electronic era, part 1. This first electronic computer using valves. Valves were developed by John Five. Athena's of in the late 190-13 is contained at subtract unit. It was relatively a small computer and used about 300 valves. Its memory unit consisted of capacitor mounted on a rotating drum. Its use of a one input or output device, including a card punch and a card reader. The first popular generation electronic digital computer was the ENIAC, electronic numerical interpreter and calculator. Next, the electronic era part 2 is John von Neumann was the consultant of the ENIAC project. The ENIAC project is the use of high-speed memory to store both program as well as data during program execution. Neumann and his colleagues designed and built the IAS computer is used from consisting of the cathode ray tube. The transistor were invented in 148 at AT&T Bell Laboratories. Slowly, they replaced vacuum tubes. Okay, in the part 2, we want to talk about computer generation. You can see at your screen, this is the process from first generation, and go now is the 5th generation. Okay, in the first generation, the digital computer using the electronic values, vacuum tubes, are known as a first generation computer. The high-cost vacuum tubes prevented their use for main memory. They stored information in the form propagating sound waves. Okay, the second generation computer used transistor for CPO component, embedded core for many memories, and magnetic disks and tapes for secondary memory. They use high-level language such as Fortran, Algol, and COBOL. Input or output processor was included to control input-output operation. In the third generation on computer use IC, or we can talk about SSI and MSI for computer CPU. Semiconductor memories were LSI chips, magnetic disks, and tapes were used as a secondary memory. Cache memory was also converted in the computer or third generation. Microprogramming, parallel memory, multiprogramming, and where is introduced AG of third generation computer RVDV2. Okay, go next is fourth generation. In the fourth generation, computer microprocessor were used as CPU VLSI. Chips were used for CPU memory and supporting chips. In the fifth generation, computer use ULC, ultra large scale integration chips. Millions of transistors are placed in a single IC on all the chips. In the 64 bits microprocessor have been developed during this period. Data flow and effic architecture of this processor have been developed RISC and CISC. Both type of design are used in modern processor, memory chips, and flash memory up to 1 GB. Hard disk up to 60 gigabyte and optical disk up to 50 gigabyte have been developed. Okay, because my battery is low, I want to charge it. Okay, sorry. Okay, I'm sorry again because the problem, technical problem. Okay, next is the Alpine 3. R40 is the last part of chapter 5. Okay, this is we can explain about the von Neumann architecture. In this type of architecture, the computer consisted of a CPU memory and I/O or input-output device. The program is stored in the memory. The CPU feeds an instruction from the memory at the time and executes it. Thus, the instructions are executed. Secondly, which is a slow process, Neumann M or C are called control flow computer because instructions are executed. Secondly, as controlled by a programmer counter. It's increased the speed parallel processing of the computer have been developed in which serial CPU are connected in parallel to solve a problem. Even in parallel computer, the basic building block are the Neumann processor. Okay, maybe that's enough for me. Okay, Iqbal.
Next, we will discuss about addressing concept that will be brought by Muhammad Afian.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afian Anwar with name 1207050065. In here, I will discuss about addressing concept. Concept of addressing in the memory. Each instruction needs data on which it has to perform the specific operation. The data may be in the accumulator, GPR, or in some specific memory location. The technique of specifying the address of the data are known as addressing modes. The important addressing modes are as follows. First, direct addressing. In this, the address of the data is specified within the instruction itself. Register addressing. In register addressing, the operands are located in the general purpose register. Register indirect addressing. In this, the address of the operand is given directly. Immediate addressing. In this, the operand given in the instruction itself. And last, relation addressing. In this, a site displacement is added to the current value of the program counter to form the effective address. Concept of pegging in context of memory. In page-oriented memory, the memory is divided into pages. One of them is a logical address. The logical address is represented by the page address and the page offset. The page address points to a descriptor table. The function of descriptor table is same as that in the case of memory segment SIM. When the demanded page is not present in the physical memory, a page fault is triggered. This forms the OS to swap the desired page. This type of memory management SIM is known as demand page virtual memory SIM. Instruction cycle. The main function of CPU is to execute program. The CPU features one instruction at a time from the memory and execute it. Then it fetches different instruction to execute it. The CPU repeats this process till it executes all the instructions of the program. Thereafter, it may take another program if any to execute. The necessary steps that the processor has to carry out for fetching an instruction from the memory and executing an instruction from the memory and executing it constitute an instruction cycle. An instruction cycle consists of two parts, fetch cycle and execute cycle. In fetch cycle, the CPU fetches the M or C code of this instruction from the memory. The necessary steps that are carried out to the fetch and opcode from the memory constitute a fetch cycle. In execute cycle, an instruction is executed. The necessary which are carried out to execute an instructions constitute our execute cycle. That's all from me. Wassalamualaikum warahmatullahi wabarakatuh.
After we get to know about addressing concept, which is brought by Muhammad Afian, then the next we will discuss about interaction and I/O subsystem that will be brought by Muhammad Sahrul.
Assalamualaikum warahmatullahi wabarakatuh. My name is M. Syahrul Anwar Arya. Now I want to explain instruction and I/O subsystem. What is an instruction? An instruction is a command given to the computer to perform a specific operation on given data. Each instruction consists of two parts, an opcode and an operand. The first part of an instruction, which specifies the operation to be performed, is known as opcode. The second part of an instruction, called operand, is the data on which computer perform the specified operation. As a computer understands instruction only in the form of 0 and 1, instruction and data are fed into the computer is a binary form. They are written in binary codes known as machine codes. For the convenience of this user, the codes can be used in lexical form. Instructions are classified into the following three types according to their word length. First, single byte instruction. Second, 2-byte instruction, and last, 3-byte instruction. I/O subsystem. IV device data and instruction are entered into a computer through IP device. An IP device converts IP data and instruction into suitable binary form which can be accepted by computer. Example IP devices are keyboard, mouse, joystick, trackball, and many more.
The OP device receives information from the computer and provides them to the user. The computer sends information to the OP device in binary code forms. The OP device counts them into a form which can be used by users, such as printed form or display on a screen. CPU your organization. First is arithmetic and logical unit. The function of an ALU is to perform basic arithmetic and logical operation. Control units. The control units of a CPU controls the entire operation of the computer. It also controls all other devices such as memory input and output device. And register. A CPU contains a number of registers to store data temporarily during the execution of a program. The number of registers differs from processor to processor. Registers are classified as follows. First, general purpose register. The registers store data and intermediate results during execution of a program. They are accessible to users through instructions if the users are working in assembly language. Second, accumulator. It's the most important GPR, having multiple functions. It's most efficient in data movement, arithmetic, and logical operation. Third, special purpose register. A CPU contains a number of special purpose registers for different purposes. They are program counter, stack pointer, instruction register, index register, memory address register, and memory buffer register. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Maybe that's the presentation of this architectural computer material. I hope you guys open up a little insight, and also I hope the presentation from our group will be useful knowledge for all of us. Maybe if anyone want to ask about material, you can discuss it in the WhatsApp group class English. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.